Plastic pollution, a very popular term thrown around nowadays for awareness, yet is still a problem that has prevailed since the 1900s. Why is that? Well, this crash course is here to hopefully enlighten you more on plastic pollution and the different solutions we can take to mitigate and eventually solve this problem. Plastics are a wide range of materials, with most plastic grades created through polymerization of different monomers obtained from fossil fuels. In the industry, numerous chemical additives can be used to induce desirable characteristics in plastics, such as cheaper cost, lightness, strength, and durability. As a result, it has a very wide range of applications, encompassing machinery, electronics, medical products, and packaging. It is evident that plastics have played a fundamental role in facilitating technological innovations, energy savings, and many other societal benefits. However, the favorable durability and non-biodegradable nature of plastics also extend until its disposal, preventing its decomposition. Apart from pyrolysis, there is no other method to eliminate plastic waste swiftly and in large amounts. Thus, they accumulate along landfills or in the environment, subsisting as waste for hundreds to even thousands of years. On a local scale, the Philippines is ranked as the third largest plastic waste producer in the world, with an annual estimated production of 2.7 million metric tons as of 2015. This can be attributed to the sachet economy in the Philippines, and also the fact that plastics are usually disposed of immediately within 1 year from its production. Our waters are also not safe from the plastic we produce on land. Due to the lightweight and buoyant properties of plastic, it is easily transported through the water currents, allowing it to reach even very remote areas along oceans. When the marine animals ingest plastics, their stomachs get filled, and this results in malnourishment and clogged digestive systems. Entanglement with plastics have also caused marine animals to suffer from lacerations, infections, and suffocation. The diversity and livelihood of our marine ecosystems are harmed by plastic pollution since it disrupts the natural order of the food chain. More than 100,000 deaths of marine mammals are associated with plastic every year. To make matters worse, plastic materials such as plastic bags, packaging, and textiles can also degrade into smaller pieces of microplastics that are a few millimeters in size. These microplastics can be consumed by organisms and thus enter the marine food chain, which eventually leads to human ingestion. Plastics are also capable of the absorption and adsorption of contaminants, such as heavy metals. This means that microplastics facilitate the entry of toxic substances into our bodies through the seafood that we eat and the water that we drink. Unfortunately, it doesn't seem like plastics will be going away anytime soon. Because of how versatile the uses of plastic materials are, it is difficult to shake off our society's reliance on plastic and its production. What we are able to do, however, is to develop and implement potential solutions for waste management and plastic degradability in order to address the problem of plastic pollution. These solutions would either discourage the use and production of plastics or hopefully allow plastic production to continue developing into something sustainable. Numerous past and ongoing plastic collection efforts help address the growing problem of plastic pollution. These include projects that promote plastic recycling and plastic repurposing, and even information campaigns regarding the importance of recycling and proper waste disposal. Even so, these solutions are only limited to mitigating the plastic wastes at the end user level rather than at the source of the plastics itself. Plastic collection efforts alone may not be able to influence the large-scale industries producing these plastics. So, we need to be a little bit more creative with new solutions. Chemical recycling is the use of heat or chemical processes in recovering monomers of plastics, which will then be used in creating new plastics. Monomers are the molecular building blocks of a polymer. So you can think of chemical recycling as disassembling a plastic at a molecular level and then using those disassembled building blocks to form new, usable plastics. The Creasolve process, invented and developed by Unilever, is a method that recovers polyethylene in plastic sachet wastes, which will then be used to create new plastic sachets for Unilever products. This technology produces a closed-loop system for plastic sachets where the plastic material is used over and over again, so the net production of new plastic is minimized. Aside from Unilever, BASF is another company that is developing their chemical recycling process. BASF has a project that turns the plastic wastes into a pyrolysis oil, which can be used as a substitute for fossil fuels. Another solution to mitigating plastic pollution is the development of new biodegradable and environmentally friendly polymer types. These biodegradable polymer substitutes are generally called bioplastics. The biodegradable aspect means that they naturally degrade over time, and are thus more environmentally friendly than common plastics. Bioplastics may also be bio-based, that is, when they are made from biomass such as corn, cassava, sugarcane, or wood. Another technology currently under investigation are biocomposed plastics. Biocomposites are made from a combination of bioplastics and natural fibers such as cotton, flax, and banana. The incorporation of natural fibers can produce favorable properties in the biocomposite material in order to better fulfill a desired use for it. In the near future, it is definitely possible for bioplastics and biocomposites to become viable alternatives to fossil-based plastics. There are already plenty of laws that mandate the regulation of plastic products or the management of plastic waste. In the Philippine setting, we have the Republic Act 9003 or the Ecological Solid Waste Management Act of 2000 that mandates and sets guidelines on proper waste disposal and management at the consumer level. We also have the Republic Act 11989 or the Extended Producer Responsibility Act of 2021, also called EPR for short. EPR is especially important since it is the only Philippine law which holds corporations and manufacturers responsible for solid waste. It mandates companies larger than the micro category to contribute to the recovery, treatment, recycling, and disposal of products after consumer use. Although there are laws and regulations regarding solid or plastic waste, it is the unfortunate case that these laws only become paper laws in some or most cases. The good news, though, is that these recent projects are being held by entities such as DENR and NEDA in order to take action towards waste management. We also have Linis Ganda, which is an NGO that manages 580 junk shops to properly collect plastics, papers, and bottles while providing incentives for participating households. Partnered with Unilever, they have collected over 230 metric tons of plastic waste already. It should be our aim as a community to have more projects and better participation in these in the future, since what good would our laws be if they are not implemented and enforced? In conclusion, the approach toward plastic pollution should be interdisciplinary and should take into account the social, manufacturing, and legislative aspects in order to develop more environmentally friendly products and processes that are also tailored to the preferences of the consumers and the manufacturers. This would ensure that the environmentally friendly alternatives would be patronized and preferred over the existing plastic types. This is necessary to create a sustainable solution to the global plastic problem. Achieving this would pave the way towards plastic-free marine environments and towards a cleaner Earth overall.